Alright everyone, this is a video demonstration of me performing the system characterization tests as listed in 2.1, 2.2, and 2.3 of the characteristics testing manual. I'll be demonstrating the outputting PWMs for both the speed curves and the steering angle curves, as well showing how I tuned the feedback control, kind of all in one go right here. So I'm going to set the integral component of ki equal to 0, and we're just going to run this program. As you can see in the bottom left-hand corner, the steering curve is outputting a PWM according to the angle. This is with, once again, 0 component. And after 20 seconds or so, this car is going to maintain kind of what I would like to call a stable orbit around that circle. It's not going to really do much of anything. You can notice that the derivative component is going to pretty much be the exact same. Yeah, it's going to be almost 0. And it's just going to do this for a little bit. So this is similar to the behavior that we want, but not exactly. Here I'm going to set this to an arbitrarily high positive value, and we can see what happens to the behavior. Once again, we can look at what is actually outputting here in the line. We have the Ki component, the Kd, Kp, as well as each of those multiplied by their respective values. With 10, we can see how it's overcorrecting way too much and eventually becomes unstable. So this is too high and not what we want. Here's the drive curve that's being outputted currently in the code. It is just pretty much set at 1 constant value, if I can find it. This is where the steer curve is being outputted. This is where the drive curve is being outputted. I might change this to how I have a formula here, but for now it's just doing an array checking method. But back to the control gains, we obviously can see that this is not what we want. So I'm going to go back and change it to a negative value to demonstrate what happens if we have a negative component. And when it's negative, it frankly just doesn't get close. It'll just kind of go off into nowhere. So we know that it shouldn't be negative, and I have found that it works best between 1 and 2, maybe 3. I found that it is strictly dependent on the velocity that you're attacking the circle. So when my velocity was much higher going around there, my Ki was around 8 to 10. But at this velocity, which I think is 1.9 meters per second, according to U, yep. And here, the car never goes beyond its kind of bounds. If you noticed, if we have the left and right edge here, it never gets outside of that. So I'd say this is the value that we want for the controller.